Hi, in this session we will consider the last problem, and here we have a hemisphere of base diameter 60 mm, and that hemisphere is placed over a frustum of a cone of base diameter 60 mm, and it is obtained by sectioning at a height of 40 mm from the base. And in this problem you have to draw the isometric view of the object. Isometric view means you can directly take the dimensions. There is no need to take the isometric scale. Isometric view means you can directly take the dimensions. First of all, you have to draw the simple plan and elevation of the object, and the object is placed in a square cage up to this limit. Up to this limit will be sufficient, and this is point 1, 2, 3 and 4, and the remaining portions are marked inside the cage, and this is the elevation. The flat portion of the hemisphere is in direct contact with the top surface of the frustum of the cone. First you have to draw the cone and you have to slice and project downward and obtain this circle. After that you have to draw the outer circle, and after that you have to mark point 1, and from point 1 you have to draw two 30-degree lines, 30-degree lines in both directions, and after that you take this dimension. This dimension is given, it is 60 mm. 60 mm is the base diameter of the frustum. So you can mark 60 mm directly on this 30-degree line. 60 mm is marked here, and another 60 mm is marked here, so that you will get the position of point 2 and point 3. From point 2 you have to draw a 30-degree line like this, and another 30-degree line in the opposite direction, and you will get another line, and the intersection, this intersection is point 3. Then from point 1, 2 and 3 you have to draw vertical projectiles, and in this vertical projector you have to mark this height, the height of the frustum. The height of the frustum is given, it is 40 mm. Here it is isometric view, so you can directly mark 40 mm on this vertical line. This height is 40 mm, this height is 40 mm, and similarly the other 2 points. And this is point 5, this is point 6, point 7 and point 8. So we finish the base portion or the surrounding glass cage. Now we have to fix the object inside the glass cage. Let us do it. First of all, we have to mark the midpoint of point 2. Side 1, 2, that is 30 mm. Marking the midpoint, 30 mm here, 30 mm here, 30 mm here, and another 30 mm here. So these are the midpoints of these 4 sides. Now connect to the opposite corner, so that you will get 2 lines like this. change. And from point 3 you have to draw to the opposite side. These two will intersect at this point and this point. Take your compass and take this radius. And draw an arc. So this is the first arc. After that, take this radius, it will be the same, and drawing another arc like this. Then take this radius in your compass and draw another arc. Slight change in my drawing should coincide. So that you will get a curve like this and another curve in this side. That completes the base portion of the cone. After that, we have to consider the top circle. And the top circle, if you consider the top circle, point E is this much distance away from this side and this much distance away from the opposite side. Or we can say that this circle is enclosed in a square, and that square, consider that square. Let us name it as, say, points up to point 8. Let us name it as point P, Q, R and S. Let us fix the position of P, Q, R and S on the top surface. Point P is this much distance away from this side and this much distance away from the other side. And these two distances are the same and it is equal to 15, around 15 mm. So here we have isometric view. So you can directly take that distance and you can mark 15 mm over the surface. Take 15 mm and mark this dimension. Take another 15 mm and mark this dimension. Take 15 mm to this direction and to this direction. Take 15 mm in this direction and another 15 mm in this direction. And similarly, you will get some points. Connect these points by means of straight lines. Then point P is the intersection of these two points. This is point, say, capital P. And point Q is the intersection of these two points, point capital Q. This is point R and this is point S. Then we have to draw an ellipse inside this parallelogram P, Q, R and S, just similar to this parallelogram 1, 2, 3 and 4. This is not 3, this is point 4. Now for that we will find the midpoint of these two sides. This is 20 mm, the distance is 30 mm, the midpoint is 15 mm. Mark that distance. Here also is 15 mm. Another 15 mm is marked here. Another 15 mm is marked here. So we got the midpoints. We can connect with the opposite corner. Let us connect that. And connecting to this one and this one, so that we'll get two intersections here and here. Take your compass and take this radius. Take this radius in your compass and draw the first arc like this. Keeping the same radius in your compass, you can draw the second arc like this. Then take this radius in your compass and you can draw another arc like this and another arc like this. So we got the top portion of the cone. Let us connect these two ellipses by means of a straight line, and this line must be tangential to the ellipses, and that completes the frustum of the cone part. Now we have to draw the isometric view of the top hemispherical portion. And if you consider the hemispherical portion, the flat portion is coinciding with the top surface of the frustum. So we can use this grid plane as the reference. Let us mark the midpoint of these points, these lines. Marking the midpoint of 5 and 6. Let us mark the midpoint, that is one point here, that is the midpoint. Another midpoint here. Another midpoint here. Another midpoint here. This is the midpoint. And let us join these midpoints by means of straight lines. Connecting to the opposite corner, and we will get points here and another intersection somewhere here. Then taking your compass and with this point as center, drawing an arc like this, so that you will get a curve like this, then with 7 as center, and the radius is equal to this one. Drawing another arc. Get an arc like this, then take this radius in your compass, and complete that smaller radius part. This radius and this radius. So that you will get an ellipse like this. So this ellipse represents the flat portion of the sphere. Now we have to draw the curved portion of the sphere, hemisphere. For that, here we have isometric view. First of all, we have to locate the center of the flat portion. By connecting the diagonals, we can locate the center. The center of the hemisphere, that is point O. Let us mark that position. Then, in this we have isometric view. For drawing the isometric view of a sphere, you have to take the actual radius of the hemisphere in your compass, and you have to mark the center. And here the center is already given, already known. We know the center of the hemisphere. And the only thing that you have to complete is the curved profile. And what is the radius of the curved profile? For obtaining the radius of the curved profile in isometric view, you have to divide the actual radius with 0.816. The radius of the hemisphere is 30. So 30 divided by 0.816 will give 37 mm. 37 mm. So that is here we have already located the center of the hemisphere. The only thing missing is the radius of the curved profile, and the radius of the curved profile is 30 divided by 0.816 because it is isometric view. So take that radius in your compass. That is 37 mm. 37 mm in your compass, and with O as center, you can draw a circle like this. And this will be the isometric view of the object. So this curve will be tangential to the ellipse here and here. This curve will tangentially meet the ellipse at this position and at this position. And this is the curved portion, and this is the flat portion of the hemisphere. And after drawing this, you have to make some changes here. We have some hidden portion. This portion is hidden, so you how to connect using dotted lines because this portion is hidden. Similarly, the central portion is hidden. This must be dotted. And here also we have a hidden portion. Like this. And that completes the third problem from isometric projections. And that is the end of our isometric projections chapter. In the next session, we will proceed to the perspective projection, and that will be the end of our graphics session. Thank you.